after discussing about these isoquants, now we will try to give you the two different types of isoquants and its shapes. Generally we have seen that isoquant is downward sloping convex curve, but what happens when the two commodities or the two inputs, not the commodities, two inputs are basically perfectly substitutable between each other. In that case, when we have two inputs which is perfectly substitutable, that I can substitute by one labor with exactly one capital or something like that, then my isoquants will be kind of straight line. My isoquants will be kind of straight lines and parallel to each other. Yes, and each of these isoquants will give you a particular level of output. Now, what does it say? Again, I can keep labor and capital over here. Now, what does it say? These, these straight isoquants, that the diminishing marginal rate of substitution, technical substitution, what we are saying, or diminishing marginal return, then when we are increasing 1 unit of capital or labor, we are sacrificing more, less and less of the other unit, isn't it? So that is the diminishing marginal rate of technical substitution. But what happens if over here I have 1 unit of labor and 3 units of capital, and over here I have 2 units of labor and 2 units of capital, and over here I have 1 unit of labor and probably 3 units of capital. That means they are technically perfectly substitutable. I am substituting 1 labor. When I am increasing 1 labor, I am sacrificing 1 capital. When I am increasing another labor, I am sacrificing 1 more capital. So they are perfectly substitutable, right? And hence you get your isoquants, which is straight lines, and when the output increases with those perfectly substitutable products, factors of production, we see output increases with more of a particular factors of production or both of the particular factors of production. If more of a one, then the other remaining same, more is better. We see the quantity of production is increasing parallelly. The isoquants are moving parallelly outwards. What happens when we have a fixed proportion production function? They are kinked isoquants. Fixed proportion. So here the productions, the factors of productions are substitutable, or I will say perfectly substitutable. Perfectly substitutable. And here in these fixed proportions production functions, they are kinked isoquants. So what we find in fixed proportions production function, that if we have the labor and capital, and I can draw my isoquants like this L shaped. These isoquants will shape L, and then this is my isoquant 1, isoquant 2, isoquant 3. Yeah, something like this. Isoquant 3, which shows 3 different level of production. Now, why do they look like this? This can eventually be, when our goods are also complementary to each other. The factors of production are complementary to each other. What does this mean? This means, let us take my labor is an X-ray machine operator and my capital is an X-ray machine. Now, one X-ray machine can be operated by one operator. Yeah. What happens if I have say 1 X-ray machine but 3 X-ray machine operator, and in a day with 1 X-ray machine I can manufacture maybe, or I can produce maybe 100 X-ray sheets, X-ray copies. Now, when I have one labor with one machine, with one X-ray machine, I can manufacture 100. When I have 2 laborers with one X-ray machine, I can manufacture 100. When I have 3 laborers with one X-ray machine, I can manufacture 100, right? Similarly, because even if I have 1000 operators, but one X-ray machine, I can maximum manufacture 100. Similarly, if I have one manufacturer, but I have 2 X-ray machines, I have 3 X-ray machines, doesn't matter, because one manufacturer can operate only one X-ray machine, or even if he is shifting, it doesn't really matter, because the total output will remain same, 100. So, on this particular isoquant, all this combination 3 capital, 1 labor, 2 capital, 1 labor, 1 capital, 1 labor, 1 labor, 1 capital, 2 labor, 1 capital, 3 labor, 1 capital will all give me 100 X-ray sheets. Similarly, if I take this example for Q2 equals say 200, here I observe that with 2 labors and 2 X-ray machines, because with 1 labor I cannot manufacture more than 100. Similarly, with 1 capital, with 1 X-ray machine I cannot manufacture more than 100. So, I must require 2 labor and 2 at least 2 labor and 2 capitals for this one X-ray 200 X-ray sheets or X-ray charts. For this I have 2 labor and 2 capital. Similarly, if I have 3 labors but 2 machine, only 200, or 3 labors, 2 machines, only 2 machines can be operated because I have 2 labors here, I can manufacture 200. So, this is a fixed proportion. So, the proportion remains fixed, which is this proportion is generally, the optimal proportion is generally given by this straight line. 1 labor 1 X-ray machine, 2 labor 2 X-ray machines, 3 labor 3 X-ray machines, and all this kink, the corner points of this L-shaped isoquants, L-shaped isoquants or kinked isoquants, that's how they are known. Yeah, so that's how they are known, kinked isoquants or L-shaped isoquants, L-shaped isoquants. Yes, shows these fixed proportion production functions or complementary factors of production. Now, going to the returns to scale, slowly we are moving towards the marriage between production and cost, and how effective that marriage will be and how efficient will be the choice, keeping the looking at the total output given the budget, and then based on that budget I will decide how many labors or capital I will recruit. Having said that, we have to think, now we have understood that we have idea about, or we can get idea about combinations of capital and labor with a given production function or with an objective or particular level of production. So, for that I need to understand that whether my capital and labor are working efficiently or not, even if cost does not come to the picture yet. So, that idea can be generated by the concept of returns to scale. Returns to scale. So, it shows it measures the relationship between the scale of production of the firm and output, that how many production, how many output, or what is the amount of production is possible given the output, the scale of output, scale of the firm or the size of the firm given the output, objective output. Now, one is increasing return to scale. Now, increasing returns, again returns is my output when my output is increasing to scale. Scale is here, what is the scale of your production, that how many laborers, how many capital you have, well, how in a hospital setup or something like that, how many doctors, how many consultants, how many surgeons, how many beds you have in your hospital. That is the production, right? That is the scale of that is a potential input that particular hospital has. So, increasing return to scale means, just taking an example, when my output increases by more than double, output increases more than double when all inputs are increased by double, or all the increased are doubled, increased by twice or doubled, all inputs are doubled. Yes, that means I increase my capital. If there were 5 capitals, I take it to 10. If there are 5 laborers, I take it to 10. 5 capital and 5 labor, if I will write my production function as, say, 100 of patients being served with 5 doctors and say 10 beds. Now, what I do, I multiply this number of doctors and number of beds by 2, and I will try to see what is the patient turnover or the treatment. Now, with this 10 doctors and 20 beds, my number of patients being treated increases by 3 times, right? So, if I can write it like this, if Q equals function of capital and labor, and when I increase my capital and labor by A units, and I observe my output, total product is increasing by B times, then if my capital and labor increases by A times, my output increases by B times, and if B is greater than A, that is the rate at which output increased, if that rate is more than the increment of the capital and labor, that rate of increase of capital and labor is, if B is greater than A, then there is an IRS, which is increasing return to scale. Over here, this is multiplied by 3 and this is multiplied by 2, and then 3 being greater than 2, I have an increasing return to scale. If I plot them, I will observe that these in isoquants, make a larger curve, and then with 5 doctors and 10 beds, I was treating 100 patients, yeah, and then with 10 doctors and 20 patients, with 20 patients and 10 doctors, if I am on this isoquant and I have 300 patients being served, then I have achieved an increasing return to scale. Yeah, And if the in increasing return to scale, actually the curves are, the isoquant curves should move closer to each other. Otherwise this 300 should have been further away, because if this is being 5 to 10, 10 to 20, it essentially should be 200, and this 300 should be somewhere here with 30, 30 and 15. But it has moved closer. This 300 has moved closer to the place of 200, which shows that during increasing return to scale, the isoquant curves will move closer to each other. And similarly, when I move from 1.5 times, say 10 to 15 and 20 to 30, capital with number of doctors and number of beds, then what I find, instead of now this is 300, instead of increasing from 300 to 450, probably I will observe that it is giving 600. That means my capital and labor increases by 1.5 units, but my increasing the output increases by two times. So that is an increasing return to scale. So whenever you have an increasing return to scale, you must invest in that, because you are getting more output than your investment. Yes, and you have to understand in which that means if you are if you can increase your scale of production and your returns are increasing more than the increment in the scale of the production, then there is a profitable input, and you are making an effective implementation. Yeah. So at the same time, when we have the constant return to scale, it is not very hard to understand that the output, when we have constant return to scale, it is CRS, it is not very difficult to understand that when I double my input, will lead to exactly doubled output. Doubled input will lead to exactly doubled output. That means if 100 was my production given 5 doctors and 10 beds, now when I increase my doctors and beds by 2 times, when I increase my doctors and bed by 2 times, and I get this 10 and 20, we can observe my output is also increasing by 2 times, and we get 200. Therefore, if I write it like this, Q equals FKL as a function of capital and labor, and B into Q is a function of AK and AL, and if my rate of increase of output is equals to the rate of increase in capital and labor, then there is a constant return to scale. This shows that there is a constant return to scale. That means how much I am increasing my scale, there is a same level of increase in the output. And if I try to draw them, then we see that the isoquants are in the equal direction. So if this is 10 and this is 5, this is my doctor and this is my hospital beds. If this is 5 and 10, and I increase if this is 5 and this is 10, and if I increase my scale by 2 units, where I have my 10 doctors and 20 beds, and I can observe that my isoquant exactly doubles. Similarly, if it increases to 15 and 30, So these three isoquants, if they are equidistant, then we have achieved a constant return to scale. Yeah, what happened in IRS? What happened? They came closer. Over here, they are equidistant. So we are on a constant return to scale. And decreasing return to scale is when decreasing return to scale DRS is when our input increases by twice, but output increases less than doubled, right? So inputs are doubled, but outputs increased by less than twice the. Yes, that means if I had hundreds of units being produced with 5 doctors and 10 beds, and if I multiply by them, increase my scale by 2 units, and we find that with these 10 doctors and 20 beds, my production is only 150 patients, which is multiplied by 1.5, and this 1.5 being lesser than 2, or if we take the previous examples, A is less than B, B is less than A when Q equals function of capital and labor, and the new production function says when I increase my capital and labor by A units, I get a BQ as my output, and where my B is less than A, it shows that I am on a decreasing returns to scale. That means my output is not actually increasing at that level how much they were supposed to increase, or at the same rate. So in the decreasing return to scale, we see that the isoquants move further away from each other. So if we have this isoquant and this with 10 and 5, say this is my doctor and this is my beds, and if I am here, then with 10 and 20, if this is 100, and then with 150 I should have 7.5 doctors and 15 beds, right? I should have 7.5 doctors and 15 beds, but I see that I am actually getting with 10 doctors and 20 beds this amount of 150, right? With far more, with maybe 15 doctors and 30 beds, I am at around say 200, but this 200 should be somewhere here. So the isoquants are moving away from each other. Yes, so now from 5 to 10, 10 to 15, you have again multiplied here by 1.5. Over here you can see that it has increased by even less than 1 time. So or just 50 units out of 150. So here it shows that the isoquants are moving far away from each other. That means the production process is inefficient. Thank you.